I can imagine how Columbus thought sitting there in Portugal looking off at the Atlantic Ocean thinking, I don't think there's sea monsters, I don't think I'm going to fall off the end of the world, but I got to get a damn boat. Mavericks is a nonprofit organization that's really working to enable others to actually build and operate vehicles into space.
Well, the mission of our group is to build rockets that have a purpose we wanted it to have. A mission in the sense of payloads and also getting as high as we could with the fuel that we were burning.
So when Mavericks goes out to conduct a mission, we also have a lot of people that are flying science missions on board, sometimes called payloads.
This is something that we came up with, we call the Payload Management Unit. SOLIDWORKS has been instrumental in the design work on this. Of course, we do some finite element analysis to make sure that it'll survive, because when one of these rockets takes off, it's under pretty high loading. This is what the experiment would have to fit into. Getting a half a dozen teams together into one vehicle gets to be a logistical nightmare. So having a standard packaging system that they can just drop their experiment into and have it all in the same vehicle is really important.
And so students play a vital role in all of this from all the universities that we work with. So they'll choose an area of innovation like a separation coupler, right? Where we need a new, cheaper, more efficient separation coupler that doesn't use high explosives.
We came up with what we call a separation ring. We use something called black powder, which is old school, like what they used in the Revolutionary War. There's electronics that fire this and allows each one of these packaging units to go in their separate way. I think the number one way that SOLIDWORKS helps us build these separation rings is the analysis tools built into the program. You can do the FEA and see the stress results, and then you can go back and tweak it and go back and forth, and that's pretty quick and seamless.
My task was to reduce weight. There's a dollar value to every pound that you have to put up there. If it weighs more, you spend more in fuel to get it there. Before we had SOLIDWORKS, I probably spent 2 weeks doing nothing but just calculations by hand on weights and distances in an effort to maximize the least amount of weight. When SOLIDWORKS came along, I could look down the axis and I could see immediately where it was off, and it took 1/10 of the time.
If you have the ability to stand on the shoulders of others, their innovations drive your innovations, which accelerates and reduces costs and increases availability for everybody. We've got a similar concept we call open source rocketry, which is to try to create a reference platform in an open source repository that people can then pick out pieces and innovate on them and then contribute back that others can then benefit from. I think what makes SOLIDWORKS really unique in terms of a computational platform, you have a combination of accessibility, integration of teams through the enterprise platform product piece, combined with mechanical analysis, flow simulation analysis, and then a great modeling tool. When you put that all together, I think it puts SOLIDWORKS in a completely different category than any other computer design package that's out there, and that's what really enables us to do what we do, and is what's going to enable what we do to enable others to do even more. Lots of people often ask the question, well, why bother with all this space stuff? But it's really tied to our destinies. And I think the exploration side is what makes space really important, because it's the last frontier. People naturally need to know what it is. Space transportation and space travel is the gateway to that unknown and to that knowledge and knowing about our purpose and how we're tied into the bigger picture of the universe.